So my name's Colin Eberhardt, and I'm Technology Director of a company called Scott Logic. And as you can probably tell by the accent, it's UK-based, so probably not terribly well known around these parts. What probably is a little bit more well-known is this stuff, Newcastle Brown Ale. The reason I'm showing that is Scott Logic is actually based in Newcastle. There's about 120 of us up there, and we do financial software. So we work for banks that you will certainly know around here, companies like JP Morgan, Morgan Stanley, that sort of thing. But the talk I'm giving today is about ReactiveCocoa and Swift. And what this is going to be is a bit of a story about ReactiveCocoa and the ideas behind it and how it has changed over time through transitioning from one language to another, both before my encounter with it in iOS world and after. So I first came across reactive programming a number of years ago when programming in Silverlight. Now, anyone here done Silverlight in the past? No? Hands up. There's one hand at the back. Anyone currently doing Silverlight? No, I didn't think so. So Silverlight was an idea that Microsoft had and that was dubbed the Flash killer. They launched this about 5 years ago to try to grab some of the market share from Flash. Unfortunately, the history didn't pan out quite like that. It was actually Steve Jobs that killed Flash rather than Microsoft. But I came across reactive extensions at this time. And reactive extensions was a framework developed by Microsoft that was a better way of programming flows of data. And I used it for all kinds of things. This is a fairly silly application, which is a mashup of Twitter, where you can tweet the UK snow hashtag and your postcode, and it will show snow on the map in real time. Because, you know, we're weather obsessed in Britain, and reactive extensions was a great tool for doing that. So when I moved to iOS development, probably a couple of years ago, I was really pleased to see a thing called ReactiveCocoa, which took the ideas behind reactive extensions and applied them to iOS development. And these are a couple of articles that I wrote a year or so ago on the Ray Wenderlich website. So if you're an iOS developer, you'll almost certainly have heard of Ray Wenderlich. And it's a great resource, and I'm one of the writers on that site. So as I said, I was really happy to see this concept that I was already familiar with available to me in iOS development. But unfortunately, it was very much marred by the language itself, by Objective-C. I can see a few people smirking here. You know what this means. If you don't want to know what it means now, you'll know what it means shortly. And this thing as well. Now, I've put little asterisks in that. You can probably guess what it says. So unfortunately, it was a great concept, but it was slightly shadowed by the language itself. More recently, Apple introduced Swift, and Swift is something that has allowed the concept of ReactiveCocoa to really shine. But before getting into that story, I want to talk a little bit about ReactiveCocoa. So just a quick show of hands. Who's used ReactiveCocoa? There's a few of you, I'd say 4 or 5. So what I'm going to do is give you a very brief introduction to ReactiveCocoa so you can understand what it is about this framework that I really like. So as I mentioned, I first came across this concept through reactive extensions in C#, the Microsoft technology. ReactiveCocoa was initially pretty much a straightforward port of the reactive extensions framework to Objective-C, and it was done by the GitHub team. What they were doing was they were writing the GitHub for Mac client, obviously in Objective-C, and they wanted something that made it easier for them to cope with flows of data, the network requests, that sort of thing. So this is what brought them to release ReactiveCocoa. So it's an open source framework. It's on GitHub, as most frameworks are these days. And what it is it's a combination of 2 concepts. The first one, functional programming, most people are probably familiar with these days. It was a slightly alien concept in the iOS world, but the Swift language has really brought functional programming to the forefront. That combined with a thing called reactive programming, which focuses on flows of data. Combine the 2 and you get functional reactive programming, which is great, but personally I find abstract concepts like this a little bit hard to understand. So what I'm going to do is describe it in my own words and in more practical terms. So every line of code that we write is executed in reaction to some sort of an event. So this could be an application lifecycle event, it could be a button press, it could be a network response. Something has to happen to execute any given line of code. But the problem is these events come in many different forms, especially in the iOS world. You've got things like KVO, NS notification, delegate pattern, target action pattern, block-based patterns. There are many different ways that events are encoded, but fundamentally, all they are is a trigger that executes your code. And what ReactiveCocoa does is it provides a common interface for all these types of events, which is great. I mean, as software developers, abstractions are our bread and butter, and ReactiveCocoa is one fantastic abstraction. It simplifies your programs as a result. But once you've got this abstraction, this simplification, something more powerful occurs. What you can do is you can define a language for manipulating and transforming and coordinating these events. So ReactiveCocoa doesn't care about the source of the event. By providing a common abstraction and an interface, it allows you to use the same language for transforming the events. So that's a slightly more practical description. What I'm going to actually do is show you some code and show you ReactiveCocoa in action. So the title of my talk is ReactiveCocoa and Swift, Better Together. So you might have expected some Swift code. I apologize in advance. I'm going to show you some Objective-C first. Believe me, it hurts me just as much as it hurts you. So this is a very trivial ReactiveCocoa example. So by adding the ReactiveCocoa framework, your various user interface elements have categories where you can access these things called signals. I'm going to show you what these are shortly, but I just want to show you some code first. So what we've got here is a text signal. We're subscribing to the text signal, and we're logging the result. So if I show you this actually running, as I type in, hello world, the logging code is being executed as a result of this subscription. So I mentioned the word signals. You're probably thinking, okay, so what's a signal? A signal is an emitter of events, and these events can then be transferred to subscribers. So every signal can have multiple subscribers. So in the previous example, you just saw a single subscriber, but you can have multiple subscribers. And these events, there's a very simple set of rules that these events conform to. These events, the signal can emit none, one, or more next events. It is then terminated either by an error or a completed event. So you can see a few simple examples at the bottom. The first is a signal that just completes. The next one fires a couple of next events and then errors. The final one is just a stream of next events. It's a very simple model, but it can be applied to pretty much everything. So if you think about, for example, a network request, the way this is encoded in ReactiveCocoa Signals is it will be a single next event that conveys the data followed by a completion. But what if it's a large download? You don't want to receive the data all in one go. So for a large download, it could be multiple next events followed by a completion, or optionally followed by error. Finally, user interface control. That's actually a never-ending stream of next events. There's no concept of completion or error for a UI control. The user can continue to tap it for ad infinitum. So with this very simple model, you can model pretty much anything asynchronous. So to get back to the code, one of the things that I mentioned early on was that once you've got this common concept, you can then start to apply operations to signals. So here, we're taking that same text signal and we're applying a filter operation to it, and then subscribing to the filtered signal and logging the result. So here, what's happening is the filter is only allowing the next events to pass if the length of the string is greater than 4 characters. Yeah, it's pretty cool. So okay, that's signals. And the events. So the events, you've got next, completed, and error. But what are events? What do they actually look like? Anything. And this is actually what makes ReactiveCocoa so powerful. Signals are an interface for handling asynchronous events, but the contents of the event is context dependent. So in this case, the context, a UI text field, the events convey text. But when you make an asynchronous network request, the next event might include some JSON data, for example. It really depends on the context of usage. So let's have a look at another example. You've seen the filter, which is a pretty common concept. You see it for filtering arrays. Map is another very common concept. So here, we're taking that text signal, we're mapping it, and returning the length this time, and then we're subscribing to the new signal and logging the result. And you could probably guessed already, as you type in the text, it's now logging the length of the string. So these are pretty trivial examples, but you can start composing them. So here, we're taking the text signal, we're doing a map, then a filter, then a subscribe. I'm not going to show you the output. You can probably guess. It's not that difficult. The important thing to note here is that at each stage, the item being returned is a signal. So each time you perform a transformation, you get back a new signal. And because at each step you're getting a signal back, this becomes a fluent API. So fluent APIs are APIs where when you perform an operation on the object, it returns the object itself, which allows you to chain invocations. It's a really popular pattern in languages like JavaScript, where you see it all over the place with things like jQuery. The previous talk I went to was on D3. It's a fluent interface. There was a talk I went to on Akka. Again, it was a fluent interface. They're all over the place, but they're not so popular in Objective-C for fairly obvious reasons. Syntactically, it doesn't work very well in Objective-C. But what this does show is that ReactiveCocoa is very good at describing flows of data. So going right back to the keynote this morning, there was a part in Tom's talk where he was talking about representing applications as flows of data using sort of block diagrams. ReactiveCocoa allows you to do this. So this is the same sequence of operations but demonstrated graphically. You can then do much more complicated things. And in a bit, I'm going to show you, I'm going to whiz through a more complicated example and build something like this. And a more complex ReactiveCocoa example might look something like this. So don't bother reading the individual lines of code. Just look at the overall shape. And to my mind, this is quite beautiful. What this does is it shows you the flow of data through your application in a single place in a very readable fashion. Also, there's no intermediate state. For the operations being performed here, there are no variables being used as flags or intermediate results. Everything is in this quite elegant flow. But it's not all roses. As I mentioned, Objective-C is not the best language for fluent interfaces, and this question on Stack Overflow that I found, I think, is a great example. Someone was asking, they were saying, I'm a newbie in Objective-C, and I would like to implement the fluent interface pattern. And the best thing isn't the answer, but one of the comments. I'll give you a second to read that. Yeah. That sums it up perfectly. So now is probably the best time to move on to Swift. So who has used Swift here? A quick show of hands. Okay, quite a few. So for those of you that don't know the background to Swift, Swift was a language that Apple have been developing for a number of years, and they released it at WWDC last year. So it's a pretty new language. It's new both in that it's only been around for a small number of months, but it's also new in that it's got a very modern feel to it. Personally, I think Apple were trying to address some of the real issues with the Objective-C language. Objective-C was really alienating certain developers who might have wanted to develop for the iOS platform. So let's have a look at Swift and how ReactiveCocoa works with Swift. So going back to my example earlier of taking a text signal, subscribing and logging, the top version is in Objective-C, the version below is in Swift. And one of the great things about Swift is you can take any Objective-C API and you can bridge it to Swift. So you can have Objective-C and Swift code working side by side in the same application. And the improvement here isn't that great, to be honest. You'll see the subscribe block in the Swift version of the code has got some fairly nasty looking stuff going on. And this is as a result of friction between Swift and Objective-C. The way that objects are represented in Objective-C, because anything can be nil, they have to be represented in this certain way with Swift. Anything that comes from an Objective-C API has to be pretty much assumed to be an any object. And the exclamation mark here is an implicitly unwrapped object, or I like to call them surprised objects. Again, this isn't great. What you can do is you can simplify things a little bit. What when I work with ReactiveCocoa and Swift, I've got a collection of little shims that basically tidy up these sort of loose edges. So rather than subscribe next, I have a subscribe next as, which is basically a crafty way of hiding this cast. So you'll see on the left-hand side, here's the original code. On the right-hand side, what it's doing is using the type parameters of the closure expression to then perform the required cast. Don't worry if that doesn't make too much sense to you. Just believe me, it tidies up the code a little bit. So what's the net result? So we take this code, and I've been wanting to use this effect for a long time, but it seems appropriate for this particular talk. You burn those horrible square brackets, and you come up with something that looks like this. It's better for a few reasons. The first one is the slightly more conventional dot syntax. The Objective-C syntax for calling methods is a little bit peculiar, the opening and closing square brackets. As I mentioned, it doesn't really lend itself terribly well to fluent interfaces, whereas the more conventional dot syntax does. The other thing that's a big improvement is that it gets rid of the block syntax, which is, again, a pretty horrible way of creating effectively anonymous functions. The closure expression syntax effectively does the same thing, but in a much neater way. Basically, this sort of brings it up to date with languages like JavaScript and ES6 arrow functions. It brings it up to date with languages like C# with lambda expressions. It makes it a much more modern feeling programming environment. But again, as I've mentioned, these are some of the little shims I've put in place to hide some of the casting nastiness. So what I want to do is show you now is all the examples I've shown you so far have been relatively trivial. What I want to do is show you a slightly less trivial application built with ReactiveCocoa so you can really see how powerful the framework is. And the application, as nearly all my example applications seem to involve searching Twitter or Flickr or something like that. I'm not terribly creative. What this application does is as you type in text, it will immediately start searching Twitter, graying out the results while it performs the search. It also queries a sentiment analysis API to determine whether it's a happy tweet, a sad tweet, or something like that. So as you type in, I think, yeah, here you go, Microsoft. You can see some angry people talking about Microsoft. Yeah, this sort of thing keeps me happy. So let's have a look at how you build this with ReactiveCocoa. So the first thing I want to do is provide, I only want to search for tweets when the text is above a certain length. There's no point in trying to search for A or E. You want a few characters before you perform a search. And also, from a user interface perspective, you want to give a visual indication of when they've typed in enough characters. So what this does is it takes the text signal and it maps it to a color based on the length of the text. What it then does is rather than using subscribe next as, it uses a convenience method, setKeyPath, to directly ensure that the background color of that text field is always synchronized with the current result of that signal, which is really cool. So you can see in the little example, as I type in text, hopefully the contrast is good enough. Based on the length of the text, it will set the background color, which is quite neat, really. So the next thing is to actually perform the search. And as I mentioned, I don't want to search for very short terms, but also there's something else much more tricky here. I don't want to issue a search every time a key is pressed, because if someone's typing quite quickly, and some people can on virtual keyboards, if someone's typing quite quickly, you're really going to start hammering that API. So what you need to do is use a concept of throttling. You want to have basically a window where if no more text is input within a certain time period, then you execute the request. It's something that you can implement yourself, but fortunately ReactiveCocoa provides that functionality for you. So you've seen the filter and this was subscribed before, but the interesting thing here is the throttle. And what this does is it throttles the next events so that it only emits a new next event after half a second if no more next events have been emitted. It's probably easier to see it in action. So at the bottom, as text is typed in, when a slight pause occurs, you can see that the text signal is then being passed through, which is really, really useful. And the great thing about this is there are no intermediate variables required to achieve this. So this is a graphical representation of the application so far. So we've got the text signal in green. We have two subscribers. One of them is filtering and setting the key path to give the background color. The other one is a throttle, then a filter, and then at the moment it's logging. So again, a nice elegant illustration of the application flow. So the next thing we want to do is search Twitter. And here's where it becomes a little bit more complicated. When you use ReactiveCocoa, the authors of the framework have conveniently added extension methods, class categories to the UI controls so that they expose signals. But you will find yourself wanting to integrate with all kinds of asynchronous things that are not exposed as signals. So what you have to do is you have to understand how to wrap asynchronous things up in signals so you can then lift them into the ReactiveCocoa world. So this is a bit of a wall of code, but what I'm going to do is just point out the key parts. So the first thing here is create signal, which is a factory method on rack signal. So this is how you create new signals. And what it does is it supplies you with a subscriber. And the subscriber is the thing that you use to emit the events for your signal. And it returns a disposable, which I'll talk about shortly. So for Twitter, iOS already has some frameworks for integrating with Twitter. They're Apple supplied. So this is just using the standard Twitter frameworks. So here's where we have to convert from a standard asynchronous API to ReactiveCocoa. So the request object has a perform request with handler method, and it's a block-based syntax, or a block-based interface, or a closure-based interface in the Swift world. So what happens is it queries Twitter, and then it invokes a function to supply the result. So the function here, what it does is it then uses the subscriber to emit the required events. So here it's emitting a next event and completed in the case of success, or an error event in the case of failure. And again, if the user hasn't got any Twitter accounts, the signal emits a different error. Finally, when you create a signal, you can return a disposable, which is used to free up any resources that were constructed when you are constructing the signal. It's basically the tidy up. So once you've got this signal, this is how you might expect to use it. So you've already seen how you can map signals, you can translate them, or you can project them from one data type to another. So you might think you can map from your text to this new signal, but this won't actually work. What would happen here is it would take the signal object, and the signal would be emitted as the next event. What you want to do is you want to take this new signal, you want to subscribe to it, and then send the events that the signal you've just subscribed to down the pipeline. Fortunately, there's a flatten map that does that for you. So flatten map is a way of switching from one signal to another. The final thing you want to do, which is a very common problem in pretty much any UI framework, every UI framework I've come across has the concept of UI thread affinity. You can only update the UI controls on the UI thread, and iOS, WPF, Silverlight, all of them, they're all the same. And so a common problem is that once you've got back a network request or something like that, you then have to marshal the invocation onto the UI thread. Fortunately, ReactiveCocoa allows you to perform this marshalling using a deliver-on operation. So you can actually switch the thread that the next event is being emitted on, which is really cool. So here you can now see this pipeline in action. As I type in some text, what's happening is it's passing through this pipeline, it's subscribing to a new signal, emitting next events, marshalling them onto the UI thread, and invoking this subscribe next block. Again, all of this code without any intermediate variables, which is pretty cool. So this is what the pipeline looks like so far. It's quite a complex pipeline of events, but programmed in quite a concise fashion. One thing I've missed off is in the iOS world, before you gain access to a user's Twitter account, you have to request access. So your user has to grant access to their Twitter account. So before we can even start doing any of this, there's another step that we have to take care of at the beginning. Fortunately, you can do this with ReactiveCocoa. So what I'm doing here is I've constructed a new signal from the process of requesting access to Twitter. I'm not going to show you the code. I'm sure you can imagine it now. You're all experts at this now. So what we're doing is we're requesting access to Twitter, and the completed event the next event will determine whether they granted access or not, and it will then complete and pass control onto my original text signal. Hopefully that makes sense. I think it still makes sense to me. And this is using the then operation, which, if you've used things like promises in JavaScript, this is very similar to the concept of then, where you chain one promise to the next in JavaScript. So this is what the application flow looks like now. So we've got 3 different signals going on here, and we've got a pipeline using all kinds of different operations and a couple of sort of subscription endpoints. Again, it's pretty elegant. But any application you write has to handle errors. So you're probably wondering, how do errors work in ReactiveCocoa? We've got these elegant pipelines, but where do errors go? This is something else that is really quite elegant with this framework. What it does is it has a sort of exception concept. Any signal that emits an error will immediately break out of the standard flow, and you can collect together all your errors in one place. So rather than just subscribing to the next event, here I'm subscribing to the next event and any error events that might have occurred, and here at the moment I'm just printing to the console. You might want to do something more useful. But you can see here that there are 3 places potentially where errors may occur. Conceivably, errors could occur anywhere in the pipeline, but they always fall through to exactly the same place, which is really cool. So at the beginning, I showed you the application. So it wasn't just a Twitter search application. That would be quite boring. What it does is it actually queries a sentiment API to determine the sentiment of these tweets. It's not a great API, to be honest, the one that I found, but hey, it was free. So how do you do this? Probably, your first guess might be that you fire a sentiment API request for every tweet and merge the 2 signals. You could do that, but that wouldn't be terribly good. That would be bad from the user's perspective, because instead of going from 1 API request, you'd be then going to 101 API requests being required before you could render any data to the user. That's not great. Also, that will end up really hammering the sentiment request API. And as I mentioned, the one I'm using is free and it's rate limited, so probably you'd hit your rate limit very quickly there. So probably a better way of doing it is to fetch the sentiment data only when cells become visible, which is a better approach, but one of the problems there is if the user scrolls very quickly to the ends of the list, which on iOS they can, I know on other mobile OSs it doesn't work quite so well, but on iOS you get a really slick scrolling. So what they could do is, in the space of about half a second, they could scroll right to the end of the list and then fire off these 100 requests. So that's a bit better, but not great. What you really want to do is fetch the sentiment data when the cells have been visible for a short period of time. So this gives you the required rate limiting, yet gives a good user experience. That sounds good, but it sounds hard work. Fortunately, it's actually quite easy with ReactiveCocoa, so I'll just show you how. This little pipeline here does all of that, and what I'm going to do is just break it down step by step to show you how it works. So the first one creates a signal. So just to set the context, this bit of code is actually within the cell class. So this is within a class which is constructed and used to render the individual cells in the table view that you see, just to give you a bit of context. So what happens is it's using a signal that emits every half a second. That's what this interval signal does. Then I'm using take one, and what this does is it takes one next event and then completes. So the net result is I've got a signal that will fire in half a second, and that's it. Then I'm using take until and supplying another signal. Now this signal emits when a cell is recycled and when it's reused. Basically, this is our method for determining when it's no longer visible. So what that does is it forms a gate which will only let the next event through if the cell has not been recycled. So this is basically the signal that we require that says a cell has been visible for a short period of time. Then we just go through the usual route of flatten, map, deliver on, subscribe, and we're done, which is really cool. So here you can see, again, you've seen this application enough times, so you search for Swift and you get mostly Taylor Swift rather than Swift, the programming language. And you're seeing the sentiment here, lots of happy Taylor Swift fans, and then lots of relatively happy Swift language fans. So at this point, I want to show you this guy. Yeah. So a few of you have done Swift development, and have you heard of curried functions before? Quick show of hands. Is anyone brave enough to explain them? No, not me either. So when Swift came out, all the functional programming nerds got very exciting because you could do things like curry functions, and people like me looked at it and went, wow, these are cool, these are amazing, but I don't think I'm ever going to use that stuff. But actually, I found myself using it quite often, and every time I do, I feel a little bit like this guy. I mean, I try not to do it too much, but, you know. So I'm going to show you where I used a curried function. This is just a bit of an aside. So on your right-hand side, you can see that little chart of the sentiment data for all the tweets. So you can see here, you know, a reasonable number of happy tweets and so on. So to render that little chart, what you have to do is, you'll have written code like this many times before if you've done any UI programming. One of the standard things you have to do is take data from one coordinate system and map it to another. So here we're taking it from the domain coordinate system, which in our case here is the number of tweets, and mapping it to the screen coordinate system. So you can take the number of tweets and turn it into a rectangle on screen. Really standard stuff. Now to turn it into a curried function, you just do this. I'm just going to flick back. You take the comma, space, put a couple of brackets in, and this becomes a curried function, which is super cool. What a curried function does is it allows you to use partial application. So you can invoke it once, and this will sort of lock in the values of the arguments you pass on the first invocation. It will give you a new function, which you can then invoke with the second set of arguments to complete the invocation. So what this means in practice is I can use my curried function to construct an X scale and a Y scale. Then when I'm actually using it to create the frame, which is basically my little rectangles, I can just give it the domain coordinate. I don't have to invoke it each time with all the screen coordinates, which is really nice. It's a nice little application of curried functions. What else is quite nice is you see the X scale and the Y scale. A little further down there's this thing called X delta. So what this is it's a function that tells me the delta, the difference between two coordinates in domain space. And what that is it's another curried function. So the delta function takes a scale, which is a partially applied curried function, to give you back a function where you can give it 2 points in the screen coordinates, and it will give you the delta in the domain coordinates. Yeah. I think that's what it says, but, you know, it's cool. Yeah, I enjoy programming. So far I've shown you how the Swift language makes ReactiveCocoa a lot better. It makes it the elegant framework that it really should have been in the first place if it wasn't for Objective-C. But it's a two-way symbiosis. ReactiveCocoa very much complements some of the concepts of Swift. So one of the things that people learned about early on with the Swift language is that it encourages immutability. There are language constructs and concepts, things like let, where you can very easily construct constants, things like structs, which can be entirely immutable. Swift really encourages immutability. And the reason for this is immutable code is much easier to reason about. It supports concurrency a lot better. It reduces bugs. ReactiveCocoa really helps with this aim as well. So the tweet sentiment application I showed you has 51 variables. Well, actually, 39 of those are constants. And without ReactiveCocoa, it would have been, 39 constants. And without ReactiveCocoa, it would have been very hard to achieve that. And obviously, the other 12 are variables. But of those 12, 6 of them are outlets, so they're not my fault. These are ones that are generated by Xcode. Another one of them is the UI window class. Again, that's not my fault either. The final 5 are UI state variables. So these are variables that are associated with UI views, which are heavyweight objects which you can't just throw away and recreate. So those are the only variables that you really cannot eliminate. Again, doing this without ReactiveCocoa, you wouldn't have had anywhere near as many constants. And again, constants result in fewer bugs, better code. So one of the final things I want to talk about a little bit is ReactiveCocoa 3. So all the code I've showed you so far is ReactiveCocoa 2, which is the current stable release. Now the team behind ReactiveCocoa started on ReactiveCocoa 3 quite a long time ago. They started on it in late 2013. And what they were doing was focusing on simplicity. There are a number of concepts in there that they realized people weren't using. So what they've done, which I think is a good thing, is they've been quite brutal about trimming out the parts that aren't working terribly well and shaping them into something new. They're quite bold about the changes they want to make, which I think is a good approach. But what happened when Swift arrived is they pretty much halted the ReactiveCocoa 3 development. They realized that there was this new language that was very well suited to ReactiveCocoa, so much of their development effort has now been on a pure Swift implementation. But ReactiveCocoa 3 isn't going to be just Swift, it's going to be both. And again, that's probably a good decision. I think whilst a lot of people are using Swift, it certainly hasn't eliminated all Objective-C code, and it's unlikely to happen in a long time. So probably the biggest change in ReactiveCocoa 3 from the Swift perspective is signals are now generic classes. So they have two type parameters. The first type parameter, T, is the type of object emitted by the next event for that signal, which is really useful. All the stuff I showed you, all that junk with subscribe next as, where I'm having to cast using my own knowledge of what is being conveyed by this event, that all goes away. It's now effectively strongly typed. The other generic is the error type as well. Now, just to show you, again, don't bother reading all that. That's the ReactiveCocoa 2 code. This is what it looks like in ReactiveCocoa 3. So that's the old, that's the new. It's not just more concise. Some of the line wrapping is different, which makes it appear more concise. But the important thing here is the closure expressions here, your anonymous functions. You do not have to supply the type parameter anymore. What this means is, you notice the $0? That's a shorthand argument syntax for closure expressions. So basically, the compiler can infer the types of the variables or constants within these closure expressions, which is really good. You're also probably wondering what this really weird-looking thing on your left-hand side is, and that's a thing called a pipe forward operator. Now, one of the other features of the Swift language is that you can define your own custom operators, and as a result, people have gone a little bit crazy and are doing all kinds of weird custom operators because it's fun. Fortunately, the team behind ReactiveCocoa haven't just created a new operator of their own. This is an operator that already exists in languages like F#, so it's already a well-recognized operator, again, which is a good thing. And I'll show you why it exists. With the ReactiveCocoa 3 signals, you might expect the operations, things like map, for example, filter, flat map, all of those to be defined as methods on the signal class. Actually, they're not. What they are is they're free functions. So they're global functions which act upon signals and return signals. And you might be wondering, why is that? And there's a distinct advantage to this approach. By having a function defined as a method on an object, you constrain its usage to that object and subclasses of that object, which is restrictive. It restricts you to OO inheritance. By defining a function as a free function, you're no longer restricted by inheritance. And the Swift language makes great use of this. The map, filter, all those operations when being applied to array-like objects are defined on the sequence type protocol. So you can apply the same map and filter functionality to any sequence type, regardless of its implementation. So this allows it to be used on dictionaries and different types of array implementation. So this is a much more flexible way of defining operations. But it has a little bit of an unfortunate side effect. So if you take this global map function, you can map a signal as you see here. But if I want to map it again, you have to, the first argument is the signal that you want to map. So it becomes sort of nested and is a little bit ugly. And as you can probably understand, I like code that looks good. And this doesn't look good anymore. And that's where the pipe forward operator comes in. So the map function in ReactiveCocoa 3 is actually a curried function where the first invocation where with the first invocation you supply it with the transformation. It then returns a function which takes a signal and transforms it into another signal. This is then coupled with the pipe forward operator that then allows you to chain these together. I'm not going to try to explain this anymore because it really makes my head hurt. And when things make my head hurt, what I do is I take a much simpler approach and try to construct my own examples. So what I've done here, the little link there means that I'll share a link at the end. What I've done here is, rather than doing it with signals, I've created my own string class and then created a fluent interface using an append member variable, then tried to re-implement it using global functions, and then re-implemented it using global curried functions with a pipe forward operator, just so I could get my head around it. So I'll share that code with you. So here is my pipe forward operator, and it's nearly happy hour, and one of the things that really struck me about this was the operator looks a little bit like a fish. You can tell it's getting to the end of the day, can't you? Not only is it getting to the end of the day, but it's also getting to the end of my talk. So just to summarize, personally, I've really enjoyed watching this evolution. So having come to functional reactive programming through reactive extensions in archaic languages like Silverlight and C#, coming to the iOS world and discovering that ReactiveCocoa is an implementation of this concept that I really love, but slightly marred by iOS. But then, happily, a good few months ago, the Swift language comes along and makes ReactiveCocoa a lot better. But not only that, ReactiveCocoa fits in very much with the ethos of Swift as well. Hopefully, this will have inspired you to give it a go yourselves if you haven't done already. And that link at the bottom gives you a link to some of the things on this presentation. So thank you very much. So, yeah, we've got time for a few questions. If there are any questions, it's happy hour in 17 minutes, so there's no reason to rush off.
Thanks a lot for the talk, Colin.
All right.
I'm curious, you mentioned that ReactiveCocoa 3 is going to be both Swift and Objective-C.
Yes.
But given that it's using things like generics and defining infix operators and stuff like that, how is that actually going to work?
Yeah, it's a little bit peculiar. It's almost two frameworks rolled into one. Basically, you will still find rack signal. You will find, well, they've got rid of rack commands, but they're replacing it with an action concept. They are still working and still putting a lot of energy into the Objective-C version as well, because they understand that we're in a period of transition. It would be a bit short-sighted of them to dump all the Objective-C code and just release a Swift version, because they would lose a lot of their current users. So what you find is there's a rack signal, which is an Objective-C signal and an Objective-C implementation of FRP, and there's a signal in Swift, which has generics and all these other things. So you'll find multiple implementations of map, multiple implementations of filter. So it does have a bit of a split personality, but to be honest, iOS development right now has quite a split personality anyway.
Fair enough, thanks.
Anyone else? Cool. All right, thanks very much, everyone.